basically something like this starts its life as a 6 metre long tube, gets cut into billets, and then on the on the machine goes to the CNC. We have made a company in Birmingham made this for us, but this is using our tooling made remotely. But even that comes in, it's finished here. All the tolerances are checked, cleaned up, deburred. So we've got, even parts that we don't make here, we outsource locally to companies we've worked with for many years. So we get some really nice work from people. Carol, who normally sits there, so that is the winding for one of our smallest, for the 504, the small wind turbine we make. So that's a 3-phase winding, so there's 3 sets of coils in there with the 3-phase output. So at that point, you've got 3-phase AC coming off of that winding with the magnet. So that can wound and configured, different sizes, different size turbines. That's for the one that you've got, that sort of size of turbine.
And that's running against the magnet effectively. And
yeah. So from this point here, those windings are compressed plastic resin.
Wow.
So that part goes in there, and then you've got the front part here.
This is like your exam, isn't it? Can you build a turbine around the magnet?
Yeah. Okay. So that's now the winding encased within the rear and front part of the generator. At that point, before it all goes together, these hubs are taken down to here. They're zapped with a whole box of capacitors and things, so they're then magnetised. So that ferrite becomes magnetised at that point. It then goes over to here, bits get bolted together, but then there's testing all the way through the process. So this is the front of one of your turbines. Yep. So that's the 2 parts moulded together, stuck together. So this is obviously the part blades clip into. So like I say, it works like a flywheel. So once it starts spinning, it doesn't really stop. Turbine, got your winding in there, output, rectifier. So what goes on here is AC, what comes off.
Are they all AC? Are they?
All the windings, and so the front end of every machine will be AC.
So you'll get some high voltage and then you bring it down.
Yeah.
Okay, all right.
And we use 3-phase, so it's a smoother output than having a single phase.
Interesting.
So your output is coming from here, it's picked up here, so you've got your 3-phase output, goes through 2 sets of brushes, which then transfers from some slip rings inside here, and then power output cable, which would obviously be dangling down. So that's the inside of one of these.
You've got 3 on the turbine that we got 2. We've got positive, negative.
Yeah,
have you got it?
No, because you've got yours is a DC. Out of it. It's rectified.
Yes.
Yeah, it's rectified in the actual unit.
Yes.
Whereas the 1200 is rectified in the controller. So you've got 3-phase AC potentially coming out of here, or 3 phases of AC.
Yes.
This is the internals of one of your furling machines, and this is it. So again, you've seen a generator. You've got the 914, which is the marine version of what you've got. That's the one on the left. The 1200 is the one in the middle, and the 1803 is the one again which isn't spinning because the batteries are full. And so when they're actually up on poles, they don't look much bigger or smaller than each other, really.
Cool, amazing. Yeah. Thank you for showing us around. Thank you so much.
I'll show you one more thing,
sure.
but you can't film this. Okay.